All right, so we've talked about importing data now. So we can now get data into R. Now the next thing we want to look at is how do we actually start doing some basic transformation with this data. So we see that this is kind of our common data analysis pipeline where we often import data, we tidy it, we'll do some transformation, visualization, model, and then communicate some results. So right now what we're doing is we did importing in the last lesson. We're kind of skipping tidying. We're going to actually get to tidying data here in the next lesson, but for right now we're going to work with data that is relatively clean and already in a tidy format. And so we're ready to do some basic transformation, and that's what we're going to jump into now. Now, there are actually many different things we can do with our data when we talk about transformation or manipulation. But there are 6 tasks that are extremely common. And when you know how to do these 6 tasks, it actually solves 80% of the common data analysis that we do on a day-to-day basis. So to perform these 6 tasks, we're going to use the Dplyr package. And the Dplyr package is part of the Tidyverse packages, and it includes a lot of functionality. Dplyr is a massive package, and it can do a lot of great stuff. But we're going to focus on just 6 tasks, and that is filtering. So filtering observations based off of some condition. Selecting specific variables of interest. Summarizing, so this is computing summary statistics across our entire data set. And then group by. So group by is some functionality where we may want to do things at certain levels within our data. So we can group by our specified levels and then do some additional operations. We can arrange our data. So this is kind of reordering the data based off of certain variables of interest. And then if we want to create new variables, or maybe we want to modify existing variables, we can do that by mutating variables. All right, so we can do all these with Dplyr. And one thing to kind of keep in mind when we go through this is there will be a common theme. And it is when we will have a data frame, we'll pass that data frame into a function. We're going to supply some additional arguments of what we want to do, but the output is going to be a data frame. All right. So we're always passing a data frame into the function, and we get a data frame out. All right. So to follow along in this, we are going to load a few packages. So we're going to load Dplyr. I'm going to go ahead and do that in the right in my RStudio session. And then we're going to use this transactions data. Right, so I'm going to go ahead and load this, and we can see transactions actually has 9 variables, and we have close to 2 million observations in here. And you can see we have like basket number, household number, purchase date, and so on. So think of this as you go grocery shopping and you have a transaction. This is each transaction. The basket number for your checkout, the household number if you are a recurring customer for that grocery store, and so on. All right, so this is the data we're going to work on. All right, so the first thing we're looking at is filtering variables, okay? And so like I said before, we're going to have a common theme with all these different functions. We have the function name, all right? And so in this case, it is called filter. We're going to filter our data. The first argument in all these functions is going to be the data, or the data frame of interest. So that's this transactions data. And then you can see we have this ... So for this case, this ... represents the conditions that we want to filter our data by. So we want to filter out for certain rows in our data, and we can specify that here. And this can actually be a single condition, or it could be multiple conditions, which we'll see here in a second. All right, so here's an example. So say we want to filter our transactions for a specific household number, right? We're interested in this household 3708. Well, we can filter our transactions data for a household number equal to 3708. So when we do a conditional statement, and we want to say something equals something else, we use a double equal sign. And we'll talk about that here in a slide or two. And now we can see that we actually reduce our number of observations in our data from, it was close to 2 million, so it was 1.8 million observations, and now we filtered it down to 565. That's how many transactions household number 3708 has made, right? So we can see every row is now related to household number 3708. Now, say we wanted to do additional filtering. Not only do we care about household 3708, but we actually want to look at all those transactions where household 3708 spent more than $3, right? So now what we can do is we specify our first condition here, which is filter for household number 3708. But then I also want to filter for spend. That's another variable in this data set right here, where the spend is more than $3, right? So now we've added two conditions in our filter statement, and we see that we've now reduced our observations down to 197. And we can continue to build on this. So we could say, hey, look, I want to look at where household number 3708 spent more than $3, and we want to exclude product number 85383. So this exclamation mark before the equal sign, this is also known as the bang operator. So this actually means not equal to, right? So now we have filtered our observations down to 176, right? So filtering is all about specifying some condition for a variable, and we're going to filter rows out of our data based off of that conditional statement. Now, for all of these, what we have done is we have not changed the actual transactions object, right? We have not overwritten transactions. We have gotten the output, right? We see the output here, but we have not actually saved this, right? So if we actually want to save the output, what we do is we assign the output from our filter statement to a new object, right? So if you are familiar with like object-oriented type of programming, such as Python, where sometimes you basically mutate the object in place, R does not do that, okay? Or at least the filtering and the Dplyr functions we see here do not do that. Okay, so what we're talking about here is we are doing conditional statements, right? And so we do that with comparison operators. And the common comparison operators we'll see are less than, greater than, equal to is the double equal sign. We have less than or equal to, greater than equal to. The bang operator in equal means not equal to. We have this nifty in surrounded by the percentage type symbols, and this means group membership, okay? And we'll talk about what that means, but it's super handy when you want to filter for rows where a certain value falls into a group of optional values. And we can also filter for missing values or non-missing values. All right, so how does this look? Well, here's some examples, right? So in this first one, we filter transactions where the week num variable is equal to 12. Or we could also filter where week num is not equal to 12. Now, if we want to look for specific week number values, say we wanted to get all those observations where the week num is equal to 1, 5, or 10, this is where we can use that group membership. So now we're saying get all those rows where week num is one of these options. This one does, we filter for spend is less than or equal to 5. Here, right, this is kind of the inverse here. What we say is we want to filter where spend, we specify spend is less than or equal to 5, but we want to get the opposite. So we add that bang operator before to say the inverse of what we specify here. And then this last one, we filter transactions where spend is actually NA. So if we want to look at all those observations where spend has a missing value, we can do that, such as this. Okay, we can also combine multiple comparison operators with these additional logic operators, right? So we can use the AND sign if we want to combine multiple comparison operators, or means we want to find one or the other. We've seen this bang operator for not, and we can also filter for when any comparison operators are true, or if we want to make sure all of them are true, right? So, okay, so what does this look like? So here's a case where we want to filter transactions where weak num equals 1 and store region equals south. Now, notice how in this case we just use this comma and we add additional comparison operators. So when we do this comma format, basically we are saying this is an AND statement. We want to filter transactions where weak equals 1 and store underscore R, the region equals south. So we could actually rewrite this in this format where we use this AND sign. Now, say we wanted to find all transactions where the store region was equal to south or equal to north. We can do that in this case where we say store equals south and we add the OR operator, store region equals north. Now, an alternative to this is to use that group membership where we say, hey, I want to filter for transactions where store is one of these options. Now, here's a quiz. Take a look at these two statements and see if you can figure out what they are actually filtering for and would you get the same results. Okay, I'll let you kind of work through that in your own time. Okay, so two common mistakes to point out. One is when you are filtering for some variable equal to a certain value. Lots of times when we first start using filter, people will just use a single equal sign, right? But when we do comparison within R, we always use a double equals, right? So if you use this, you will get an error. And the correct way to do it is to say, I want to filter for transactions where store region equals, double equal sign, south. Okay. Another one is for getting quotes, right? So if you are looking to basically, especially for a character string, a variable that is made up of character strings, if you were to specify, I want to find store region equals south, but not with quotes, it's going to think that this is actually some object, right? Some variable that you have created within R, right? Which will not be available. So you will likely get an error there. And what you're trying to do is to say, I want to find where store region, the values in store region are equal to south, which is a character string. Right, so those are just two things that are very common when you first get going. Just keep an eye out for that. All right, so what I want you to do, pause the video, and I want you to work through this challenge. Import the transactions data if you have not already done so, as we've been going through these slides, and if you have not been following along, go ahead and import that data. And I want you to work through these additional 3 filtering processes, okay? All right, I hope you got through that. So let's take a look here. Here we've imported our data. In this case, I used the read underscore CSV function. Now for the first one here, filter for transactions with greater than 2 units. So here I want to take my transactions, and if we look at transactions data here, we have a units variable. And I want to find where units are greater than 2, right? So if you did this, you would have gotten 93,973 observations, right? And now if I look at units here, we can see all our values are greater than 2. Number 3 here says filter for transaction with greater than 2 units during week 101 that occurred in the South region. All right, so these are all pretty much and statements, right? Where we are saying we want to, let me go ahead and find this. Oh, I don't have this in here, so let's go ahead and write this out. I want to filter transactions where units is greater than 2, week num is equal to 101, and what was the other one? The store region is equal to South, right? And when I do that, I get 300 observations. And the last one was pretty much the same thing, except it says filter for transactions with greater than 2 units during week 101 that occurred in the South or Central regions. So what I could actually do is take this last condition here, where I had store R is equal to South, and instead I could say, let's do group membership, and I want it to be either South or Central. And now I get 717 observations. All right, so that's filtering. Now let's take a look at how we select variables. So select is the nicely named function to do this. And the same type of pattern applies, right? We have our select function, and the first argument is going to be data. And then we're going to pass the variables of interest that we want to actually select. So what does this look like? So say we wanted to only get certain variables in our transactions data. In particular, we care about the product number, the spend, the units, the store region, and the week num, right? So we could select just those variables by basically specifying them within our select function. And we just separate the variables of interest with the comma. Now, another thing that we could do, right? So if we look over here on the right and I look at my transactions, and we can see that here we are selecting product number, which starts right here, and we're getting spend, unit, store region, and week num, right? So these are all columns that basically follow one another. Well, a handy function or capability we can do within select is we could say, hey, look, I want to select the product number variable and the week number variable, which are two bookends, and I want to get all the variables in between. And that's what this colon specifies. So it's basically saying get basically everything, including these two, so including these two variables and everything in between. All right, so that's fairly simple. Nothing special about that. But what is really handy are these additional helper functions that select works with. Okay, so often we want to select certain columns based off of a pattern in the name, right? And we can do this with these additional functions: start with, ends with, contains, and matches, right? So we have several variables within our transactions data that end with num, right? We have basket number, household number, product number, week number. And say we wanted to select all those variables, right? So we could say select within the transactions data frame all those variables that end with num. And now we see in return, we get all those variables that end with num. Right? We could also say, hey, look, I want to select all the variables that contain some pattern within them, whether they start with it or end with it. For example, we have several variables that have underscore within their name, right? A lot of these are in the middle of the name, and then purchase has it at the end, right? So I could say select all those variables that contain underscore somewhere within their name, and we see that we get those variables in return, right? And we can actually combine different types of helpers, right? So here we're actually saying I want to select the variables from transactions. That includes, I want to get the year variable. I want to get all those variables that end with num and all the variables that contain underscore, right? So notice how we combine all of these together in one select statement, right? So that's pretty handy. So we can get many different variables easily by identifying the patterns in the name that we want to select them with. All right, so what I want you to do is to go ahead, and there is a household CSV data set that came in the download for this lesson. And I want you to import that data set. And then in there, I want you to go ahead and select all the columns that contain underscore. And then I want you to follow up that and filter for those observations that fall in the 75 to 99,000 income range. All right, so I hope you got through that. So let's go ahead. We're going to import our households data. And we can take a look at households. And we see we have, for each household number, we have a bunch of different demographic information. We have their age range, we have their marital status, their income range, are they homeowners or not, and so on. And so in here, what we want to do is select all the columns that contain underscore, right? So to do that, we could use this select households that contains underscore. And we see we would get household num, we'd get age range, income range, household composition, and HH, which stands for household size. And then what we want to do is from that data set that we saved, so in this example, I saved this just as reduced data frame, which is not the most informative, but it works for now. And I'm going to use that, and now I'm going to filter for those households where the income range is 75 to 99K, right? And so you should get 594 households. All right, so we have filtered our data. We have selected certain columns. Next thing, let's look at arrange. How do we basically reorder the rows in our data based on certain columns, right? So same pattern exists. We have an arrange function. First argument is data, and then we're going to pass it the columns of interest that we want to order our data by. All right, so there's two different options. We can order our data in ascending order, which is the default, or in descending order, right? So if we wanted to arrange all our rows and transactions based off of spend, we could do it. So we are going to arrange transactions based off of the variable of interest spend, and we see that now spend is all the way down at negative $15. So this is apparently returns where what the customer walked away with was actually $15 in credit for some reason, right? But now if I wanted to arrange our rows to see those rows that had the largest amount of spend, I can use this DESC function here, which means descending. And so that's going to say, let's arrange our rows based off of a descending order of the spend variable. And now I see that the transaction where they had the highest spend was $282. The next one was $276, and so on. So we have all our rows ordered in a way where it goes from the highest amount of spend down to the lowest. All right, one thing to kind of note here is that arrange will always place missing values at the bottom. So don't think you can just reorder your data and try to get those rows with missing values come to the top. That's not how it works. No matter which way you do it, so here's just a very simple data frame with one column, and we can see we have NA here at the bottom. And if I arrange this data frame either in ascending or descending order, you can see arrange always places the NA at the bottom. So just an FYI. All right, so what I want you to do here is work through this your turn. What I want you to do is take the transactions data and arrange it by the week number in ascending order. Then I want you to arrange transactions by week num in ascending order, but then arrange the spend in descending order. All right, so what we're going to look at is all those transactions that have the most recent week number, but where we're looking at spend at the greatest to the least. And then I want you to go ahead and see if you can figure out what happens when you arrange an alphabetical variable such as store, like a character string variable. How does arrange treat those? All right, assuming you work through those, this is how we'd approach this. So number one, arrange transactions by week num in ascending order. Well, this is pretty straightforward. We just use arrange, and we're going to arrange the transactions data frame by the week num, and by default it will do it in ascending order. Now, what if we wanted to arrange the transactions where week num is in ascending order, but within each week we want to order the rows based off of spend and decreasing, right? So here, if we take a look before I execute this, we can see that week num in ascending order, so it starts at 53, but we have spend not ordered whatsoever when we look at this column here. Now when I run this, now we have week num starting at 53, but spend within the week num 53, we have spend ordered in decreasing values or descending order. Now what happens when we arrange by a character string or alphabetic type of variable? Well, here I arrange in descending order, and we see that the store region is west. What if I do it in ascending, which would be the default? We see that it is central, right? So all it's doing is it's ordering that variable based off of alphabetical order of the values in them. All right, so we have filtered our data, we have selected certain variables of interest, and we've figured out how do we reorder our data based off of certain variables. Now let's talk about how do we compute summary statistics across our data, right? There is a function that is called summarize. And what we do here is, again, we pass summarize the data frame of interest, and then here we're going to go ahead and we're going to pass one or more summary statistic functions to compute. So what does this look like? Well, say we wanted to compute the average spend of transactions, right? So recall, within transactions, we have this spend variable. If we wanted to get the average spend across all observations, what we can do is we take summarize, we pass it our transactions data, and then what we do is we can name what this output is going to be. So I could say, I want to compute the average spend. I'm going to name it average spend. All right, so this is not naming the data frame. This is actually naming the column that's going to contain the summary statistic. So I'm going to have average spend is equal to the mean, which we've seen that before, of the spend variable. Okay. And in this case, I'm not too sure if we have missing variables or not, or missing values. So I'm going to go ahead and just pass na.rm equals true, so that if there are missing values, it removes those values before computing the mean. So now what I get in return is still a data frame, but it's only got one column and one row, and it's the average spend, right? So the column that we get in return is the name that we specified here. And the average spend across all observations is $3.61. So $3.61. Now the thing is, we can compute more than one summary statistic within the same summarize function. So say I wanted to compute the mean of the spend. I also want to compute the standard deviation of our spend to kind of give me the idea of variability. And then I want to get the number. So there's this n function, which will tell me the number of observations within our data set. So in in return, I get a data frame that now has 3 columns where I get the average spend, the spend standard deviation, and I get the number of observations. All right, so there's all kinds of functions that we can apply within Summarize. So think of any function that is going to take multiple values and summarize it down into one value, right? So let's say the min of a vector, the max of a vector, the mean, the median, the sum, the variance, right? Everything, the one thing that all these functions have in common is they take multiple values and they reduce them down to a single output, right? Any function that does that, we can actually supply that in Summarize. Now, the thing is, what we're doing is we're summarizing across the entire data set. And that's very useful, but lots of times we want to compute summary statistics for different levels within our data, right? So for example, within our data, we have multiple weeks, right? We actually have weeks that range from something like, well, let's see. Let me take the summary of transactions, week num. And so we have week numbers 53 to 104, right? So we have transactions across all those weeks. So just a little bit over 50 weeks. What if I want to compute the average spend per week, right? What we can do is we can use this group by function. So the first thing I do is I want to group my data, group my transaction data by the week num variable. Now when I pass that into Summarize, so we save this output as by week, and I pass that into Summarize, and now I compute the average spend. What happens is instead of getting a single summary statistic value, we get that summary statistic for every single week, right? The variable that we group by, we get the summary statistic for each value in that variable. So now we can see week number 53 had an average spend of $3.51. Week 54 had average spend of $3.49, and so on, right? So similarly, say we want to compute the variability of spend by store region. Well, what we would do then is we would group our transactions data by the store region variable. I save that output as by region. I pass that into Summarize, and then I say I want to get the standard deviation of spend, right? I save that here as delay underscore SD. I'm not exactly sure why that's not a good name here, but basically what that's doing is just the standard deviation of the spend variable. So now I can see the variability of spend for each value or each region that is contained within the store underscore R variable. All right, so what I want you to do is kind of put this knowledge to test, and I want you to compute the average spend by household number and arrange in descending order to find the household with the largest average spend. Then I want you to find the products, which use the product num variable, with the largest median spend. All right, so how do we do this? Well, we got a few multiple steps to do. So let's look at number 1, compute the average spend by household number. The first thing we need to do is group our transactions data by household number. So I do that, and I save that output as this household group. Then the next step is I want to summarize that household group data frame, and I want to get the average spend. So I use mean of the spend variable. I save that output as household spend, and then I arrange household spend in descending order. And what I can do, if I run this code here, you see that household number 3693 has the largest average spend with $51. All right, so to find the products with the largest median spend, very similar. We group our transactions data by the product number. I save that output. Now I pass that output into summarize, and I get the median. I compute the median spend for each product. I save that as product spend, and then I use arrange to order that in descending order. So let me run these 3 lines of code, and we see that product number 5232147 has the largest median spend at $260. All right, so in this last your turn, you notice kind of a common theme where we were grouping by a certain variable within our data frame. We did some summarizing, and then we did some sorting. And to do that, what we would do is we'd run these 3 different lines of code where we'd group by some variable, we'd save that output. We'd pass that output into summarize, compute some summary statistic, and we'd save that output. Then we'd go ahead and arrange that object by some variable, okay? Now, that's fine, but the only reason that we're saving the output here in a variable is in order to pass it on to the next function, right? That's probably not the most efficient way to do it. And also, when we read through the code, it just requires an additional step in kind of following what's going on in the logic of the code. We can actually simplify this. And we can simplify this by using the pipe operator, okay? So think about traditional approach to writing code, which is what we've been doing, where we compute some type of output and we save that, and then we pass it in as an argument, right? So here we have, we would pass prod group in as that first argument here, x, in this function. We'd save that output and we pass that as the first argument within the range function, okay? The pipe operator actually allows us to take the output of one line of code and to pass it in as the first argument in the next function, right? So rather than write our code like this, what we can do is write our code in this way, where we say, let's take our transactions and then let's group by product num and then summarize our spend variable, get the median spend, and then we have another pipe operator here, and then arrange in descending order the spend median. All right, so here we're not saving any output along the way. We can actually string together many different functions to do some analysis, and then we could save that final output if necessary, right? So this is actually far more efficient, and you'll find that as we start writing code in this way, it becomes much easier to follow, right? When you see this pipe operator symbol, just treat it as and then, right? I take some data and then I do some function and then I take that output and then I do some more operations and then I take that output and I do more. So what I want you to do is use the pipe operator to take the transactions data, filter for southern region stores only, and then group by product, and then compute the average spend, and then sort this output to find the product with the largest average spend. All right, so what our code looks like is this. So we take our transactions data, and then we're going to filter the store region to equal south. That's our first step. And then I take the output and I group by product number, which was step 2. And then I take that output and I summarize and get the average spend. So I take the mean spend, which was step 3. And then I take that output and I arrange in descending order that spend average, which was the variable I created, which is the mean spend. Right? And we see that the product number with the largest average spend, and average being the mean, is product number 1144005. All right, so we have figured out how to filter data, select variables of interest, reorder our data based off of certain variables. We figured out how to do summary statistics both across the entire data frame and also within certain groups of our data. And we've also looked at how can we chain some of these functionalities together with the pipe operator. The last thing we're going to look at is mutate. So mutate is when we want to either create a new variable within our data frame or we want to actually change an existing variable. So the same thing applies where the first argument within mutate, the mutate function is the data. And then we follow with one or more new variables that we want to create. So what this will look like is, let's say I want to take our transactions data and I want to create a price per unit variable. And this variable, this is going to be a new variable we add, is going to be equal to spend divided by units. So notice that these are two variables that exist within our data frame, right? We have spend and we have units. And what we actually do is we create price per unit, which is a function of these two, right? And so here we get our output, price per unit, which we can see is simply spend divided by the units for each row, right? So this is going to be element-wise, like vector type of operation. All right, so we can actually create multiple variables within one mutate. So here we do a few things. Just note I group by week number and I compute the total spend and total units per week. And then what I actually do is I follow with the mutate where I want to create multiple variables. My first one is create the average spend per unit, which equals spend divided by units. Then what I do is I create a new variable this is the week over week % growth. And note how this variable is actually a function of this variable that I just created. So when we create new variables within mutate, it'll do it in a sequential order. That means any variable that we create up here, right? If we want to create a new variable, we can use this variable, right? Because it'll be computed by the time we get to creating this new variable down here, right? So the main thing here, don't worry too much about exactly the different functions we're doing in here. Just realize that when we mutate and create new variables, we can do multiple new variables in one mutate function call. All right, so how can we create new variables? There's a lot of different functions, and this is just something that over time you will start to learn about the different functions that we can use and start applying them in different use cases, right? So we can do any kind of basic arithmetic to create a new variable. We could use, here is one where we're going to take x, so the value divided by all the values in a column. We can do modular arithmetic. We can do transformations such as take the logarithmic value or the square root of a value. We can do offsets so we can lag and lead certain variables and so on. So there's a lot of different things that we can do within mutate to create new variables based off of different type of operators. All right, so what I want you to do is, using what you've learned thus far, can you find the store region and week that experienced the greatest week over week growth in the number of units sold? And so you can see I've got the kind of the sequence of functions that you want to use, and I've made some notes here what you want to do. Group by region and week, compute the sum of units, create the week over week difference, and check out the lag function that may help, and then arrange in descending order. So pause the video, take several minutes, see if you can work through this, and then we'll go through it in a second. All right, so hopefully you made some progress here. So the way to accomplish this is, first we take transactions, and then we group by the store region and the week number. And then we're going to summarize the units, so we get the sum of units. And then I'm going to create two new variables. The first one is going to be the week over week units. So this is the units sold in the current week minus the units sold in the previous week. And then I can use that information also to get the week over week percentage, right? So we can see if I ran just this code, here I get my week over week units and I get my week over week percentage. Now we get these NAs at the beginning. That's because we do this offset, the lags. So we're taking the value from the previous week. So I'm taking this units here for week 54, the total units, and I am using the lag to take this previous weeks to do our computation, right? So we're taking this week's number of units minus the previous weeks. And then if we arrange that, we can see that we get the store region East, week number 103, experienced the largest week over week percentage change in the number of units sold. All right, so to wrap things up, key things to remember. Dplyr has a lot of functionality that you'll find useful and that you will learn over time. But the 6 functions that are going to serve vast majority of the use cases you need to do basic data manipulation and transformation is going to be filter, to filter certain observations based off a conditional statement, selecting certain variables, and we can summarize both across the entire data frame, and we can do summary statistics grouped by certain levels within your data. And then we can use arrange to reorder our data and mutate to either change existing variables or create new variables. And we can knit any of these functions together using that pipe operator. All right, so there's a lot of stuff that we covered here. Remembering it all can be difficult. There's a great cheat sheet available. You can find these cheat sheets under, let's see, if you are within RStudio, if you go to help, you can see cheat sheets. And then here, this data transformation with Dplyr will be one that is applicable to everything that you saw in this lesson. All right. So if you got any additional questions, I would say, first of all, go through the lesson reading. There's more information there. There's actually more exercises to get you applying some of this stuff that'll help kind of like let it sink in, get you used to doing actual Dplyr code. And if you still have questions after that, go ahead and hit up the discussion board on Canvas.